Welcome everyone. Uh, we are here basically to start off the space launch course for this semester. Well, you've been exposed to satellite technology last semester, and this semester we are going to look into space launch, particularly rocket technology, in order for us to carry that particular payload, or rather the satellite, into its orbit. Now, you have seen various subsystems in the satellite technology itself. Rocket technology, or rather the launch system, is going to consist of lots of, well, I would say technology, or rather lots of content regarding the engine itself. So you'll be exposed to types of rockets, and what are the options basically for you to choose those rockets, and eventually basically to ensure that your satellite, or rather your payload, will be put into its orbit. So that would be basically the content of most of the items that we're going to cover this semester. Performance is also important that we will have a look at it. So let's look at what is in store for you semester. Please do have a check whether you are registered in the course Space Launch Technology, EAS 3514, 3 credits, 3 hours a week. There is technically no tutorial, but then we do lots of exercises for you to get familiar with the rocket performance, etc. Typically, you can expect chapters. Like today, I'm going to give you a bit on overview, then straight move on to one of the most important chapter, basically on rocket equation, or rather velocity equation. We're going to see how the basic rocket is being modeled, how basically the basic or the fundamental of the rocket is being translated into equations for us to look into the actual performance of the rocket. Then we will go into types of rocket. For example, thermal rockets. That's very common. We will dissect that chapter, then look into the options that we have, what are basically is available, and what are the performance that actually you can have with thermal rocket. Then we will deep dive into thermal rocket design. We will look into some very important parameters, because designing a rocket that will happen basically in your terrestrial situation or environment. But again, the rocket performance is basically going to go in almost up to space. So therefore, there is a lot of basically trade-off to be done, and we will look at the critical parameters that is very, very important for that engine technology. Again, rocket is all about the engine technology. That we will see how this can be actually I would say exploited. Then moving on, we will also look into electrical rocket engines. Those kind of engines are very, very, very interesting in terms of interplanetary mission, for example. Then I think those are the good options actually for us to consider when you want to do interplanetary mission. Although our focus is going to be Earth-oriented mission, but then I think more and more we see lots of interplanetary missions are coming up in the world. So I think it's good to know what are the propulsion options that we have in that sense. Then we'll do a bit on rocket control itself. Then to see how basically for us to ensure the rocket actually respects the trajectory that we design, so that actually it's going to hit the basic injection point. Last but not least, launch docking, then undocking and re-entry. So this is very important, because we are also sending well, astronauts into space. We need to bring them back safely. So what are the technologies available, and what are the performance actually normally we look into when you do basically a manned mission, so to say. We have talked about satellite last semester. We are going to put your payload into the rocket, and the rocket actually is going to fly. But then when you put the payload as the human, then it will be a manned mission. So basically, you don't bring the rocket, we don't bring that satellite back home. Satellite is going to just end up being a debris in the space, but then you will end up actually bringing your astronauts back to home. So there is a technology basically available in order for us to do so. So we will see that, and there's going to be a very, very tight window for us to work on. So it's going to be interesting. And what are the vehicle or design that we have, as an option? We will look into that as well. So expected outcome has been classified, or that has been specified in your course outline. Basically, you are supposed to be able to differentiate the type of rocket engines and their performance. For sure, we will cover lots of actually performance calculation. We need to actually know the actual control system for the rocket space launch. In fact, you will know basically how the phases that the rocket has to go through in order for it to deliver its payload into its orbit. Then, of course, you have to also look into, or rather being exposed to, planned launching phases of a space mission. As I've said, the most exciting one, the complete mission, would be you take a human basically into space, then you bring him back. So that will be a complete basically cycle. That will be also will be exposed, and that is your expected outcome. Evaluation, a bit more flexible on this evaluation, how this course is going to be evaluated. Attendance, although it's going to be virtual, but I think it is important to attend, especially that online or virtual classes. That's very important. And your attendance also will be actually reflected into your Putra Blast, so to say. That accounts for 5%, and then group project, we'll have a one semester project, or the group project. We'll be having a small group basically to work on a particular project on the subject matter, this rocket. 35%, expect maybe the group report might be just 20%, and then we have a progressive presentation, 15%. A midterm test, we will have that probably in the week 7, more often than not. That will account for 20% of the whole mark, and obviously final exam, that will be about 40%. And note that final exam might be a face-to-face exam, and the coursework 60% is going to be in online mode or virtual mode, but yet I'm quite sure that actually we can cover quite a bit in that sense compared to the face-to-face mode. So I don't think any problem in that sense. We are supposed to cover the same material, and the understanding, we cannot compromise in terms of the understanding as well. The references, typically, well, there's lots of references available in terms of rocket technology, but please bear in mind that most of those, I would say, books or other references are quite general in that sense. Well, rocket technology is very, very sensitive. Therefore, I think the insight of rocket technology itself, it is not, I would say, available freely just like that, because sometimes the information are classified, etc. So therefore, you've got to be very, very careful of choosing the references. You may not talk about the holistic approach of designing a rocket. And nevertheless, if you look at all those lectures that actually I'm going to provide, and including its lecture notes, that are basically collections of not only the research, but also lots of other, well, sort of unpublished work. It's not a textbook work, and so on. So lots of derivations available, which you can't find practically in the typical textbooks. So that what I want to say here is that with lecture notes, I think you'll be doing just fine. And with our exercises, I think you will even do even better in terms of the understanding for you to complete this whole course on space launch technology this semester. Again, feel free. You can actually have a look at that references. You can read. It's for your knowledge. I don't even stop that. Good readings always helps. Thank you. I think that's all.